Hello everyone and welcome to this tutorial. Today I am going to show you how to create a simple calculator using Java and the Swing toolkit. This is a good starting project if you already know something about Java or at least programming in general, but you have never created a graphical interface and now you want to learn how to do that. Everything I'm going to do here is already on GitHub. Check the description for the link to the repository. You will find the full code and a more advanced version of the calculator. The rest of this video is divided into 3 sections: project setup, creation of the interface, and the creation of the logic. The bar is broken up so that if you want to move between sections, you can do that. And now let's start by setting up our project. Okay, the first thing that you have to do is to open your IDE. If you don't have one, you can download IntelliJ. Just Google it, you're going to find it as the first result, and download the Community Edition. I use IntelliJ because I like it. If you want to use something else, it's absolutely fine. You also need a Java Development Kit or a JDK. If you don't have one installed, Google Java JDK. Again, first result. If you are on Windows or macOS, download the installer and just run the installation. Now that we have everything, it's time to create our project. I will show you the process for IntelliJ. Click New Project, name it Simple Java Calculator. Select the location, I'm just going to create it on my desktop. Select the JDK if it's not already selected, and click Create. This is going to create our empty project. Now, first of all, we don't want to develop inside the main class. The main is supposed to be the entry point of your project and you should write as less code as possible inside it. To contain our code, we can create the calculator class. Right-click on Source, New, Java class, and name it Calculator. Inside our main, delete the print line and write New Calculator. And from now on, we are only going to work inside the calculator class. At the top, let's write our import. In order to create the interface, we will be using several libraries from the Java Swing and the WT packages. Javax.swing is for the Swing containers and components, such as the window, the main text field, and the buttons. Java.awt and java.awt.event will be used for setting certain parameters of the interface and handling button events. And the line border is something to apply a personalized border to the main text field. Now that we have written our imports, we will start by creating a basic empty interface. Inside the calculator class, declare a JFrame, and inside the constructor, write this code. First of all, we have created the JFrame. A JFrame is a top-level container of Swing, and we need it to contain the elements of the interface. The JFrame constructor takes one parameter, which is the title of the window that will be created. SetDefault close operation defines how the interface should behave when we press the close button. There are multiple possible behaviors, but in our case it's simply going to close the program. With setSize, we can define the size of the window by specifying the width and the height in pixels. SetLayoutNull removes the default border layout of the JFrame, and SetResizable false do not allow the user to resize the window. In the end, we run the setVisible method to show the interface on the screen. It's a good practice to run this command after all the others because it makes sense to define the interface and then show the final result when all the components have been created. Now that we have our working empty interface, we can start adding components, and the first one we are going to add is the main text field. First of all, add a new JText field to the calculator class. It's going to be needed later for the logic. And then write the code in the constructor. The first line declares a new font. This is the font that we will use inside the text field. Cambria Matte is the name of the typeface, bold is the style, and 40 is the size of the text. We then declare a new JText field and assign its value to the class attribute. We use the setBound method to define how the text field will be placed inside the interface. The x and y coordinates define the position of the text field on the x and y axes, and the width and height define the size. The setFont method assigns the font that you have previously created to the text field. SetHorizontal alignment aligns the characters inside the text field to the right edge, as you would expect in a calculator. And setEditable false removes the possibility to directly modify the value inside the text field. We then add the line border to make the text field easier to see on screen. To do that, we declare a new line border. It needs a color and a thickness value. We set the value inside the text field to an empty string, and in the end we add the JText field to the JFrame. Now we have finished adding the main text field to our interface, and we can add the buttons. To do this, we first add two attributes to our calculator class. We create two arrays, one to hold the references to our numeric buttons, the numbers between 0 and 9, and the other to hold the references to the functional buttons, basically the other ones. We are also going to add 8 more attributes, one for each functional button. This might seem confusing if you're not familiar with Java, but by doing that we can store the references to our functional buttons both in the funcButtons array and in the individual JButton attributes. The references will be different, but the JButton objects will be the same. This will make our life much easier when we are going to create the logic of the calculator. Let's now create the numeric buttons. We create a new font that we will use for all the buttons of the interface. The typeface is again Cambria Matte, but this time the size is 25 instead of 40. We then loop over our numeric buttons array, and for each element we create a new JButton. The JButton argument is the text that is displayed inside the button, and for the numeric buttons we can use the string value of the position inside the array. We then set the font with the method setFont, as we did before with the main text field. We add the calculator class as an action listener. We can comment this line for now. This will be important later when we are going to add the logic of the calculator. For now, you just need to know that we need this line because the buttons need a function to call when we are going to click them. We set the button as not focusable with the setFocusable false. And as last operation in the loop, we add the new instance of the button to the array. With that, our numeric buttons are created. Let's now focus on the functional ones. We first instantiate them using the attributes within the calculator class. Every button contains a different text based on the operation it needs to perform. Then we add the functional buttons to the funcButtons array. This will make it easier to apply changes to all of them, as we are going to see in a moment. After that, we loop through the funcButtons array to set the font, add the action listener, and make the buttons not focusable. With that, we have created our buttons, but if we start the calculator now, we would not see them on the interface. To see them, we need to place them and add them to the JFrame. Now, we can use some math and place them individually inside the interface, but this would be difficult and not very useful. Instead, we can use a grid layout to make the process much simpler while learning a few things about them. First, we need to create a JPanel, which is a lightweight container that can be added to the JFrame and will contain our buttons. We set its bounds and layout, then we add it to the JFrame so that it's visible. We set the background color of the JPanel to gray so that we can see where it is within the interface, but we will remove the background color later. Let's now focus on the grid layout and its parameters. A grid layout is a layout manager that automatically determines where the components will be placed when added to the JPanel. A grid layout arranges the components in a grid and takes 4 parameters: the number of rows, the number of columns, and the horizontal and vertical gaps between components, H gap and V gap. In our case, we will use 4 rows, 4 columns, horizontal gap and a vertical gap of 10 pixels. This means that we will place our buttons in a 4x4 grid with a gap of 10 pixels between each button. At this point, we can easily place the components by simply adding them to the JPanel. And this is all we need to do to add most of the buttons to our interface. We still need to add 2 buttons, the equals and the plus buttons. To do that, we just manually set their bounds and add them to the JFrame. And that's it for creating the interface. If we start the calculator, we see that all the buttons are in the right position. However, if we click them, nothing happens. To make them work, we need to add the logic of the calculator, and this is what we are going to focus on now. First, we make the calculator class implement the action listener interface. Go to the beginning of the calculator class and after the name write implements action listener. By doing that, you are guaranteeing that the calculator class has an action perform method that can be called when an event happens. Next, go to the end of the calculator class and write the action perform method. This method will be called every time the user clicks a button on our interface, and you can leave it empty for now. Now go inside the constructor and where we have created the numeric and functional buttons, remove the comments from the add action listener calls. You now see that these lines no longer give you an error since the calculator class now implements the action listener interface and is guaranteed to have the action perform method. At this point, we have everything we need to write the logic of our calculator, and we can now focus on the action perform method. This method is going to get called once for every event generated by the interface, in our case when a button is pressed. We can assume that the source of the event is one of the JButtons of our interface, so we can immediately cast the source of the event to a JButton object. To check if the button that generated the event is a numeric button, we loop over the numeric buttons array. Inside the loop, we check if the button is the element in position I, and if the check is true, we get the string value of the number from the text inside the button, and we append it to the text field by using the getText and setText method. Now, before checking the result, we are going to implement the dot button. To do that, we just need to check if the source of the event is the dot button, and when that happens, append to the value of the text field a string that contains a dot. Now let's run the calculator and see the current result. If we click on the numeric buttons and the dot button, the calculator works as expected. However, the other functional buttons do not work yet. To fix this, we need to add their logic to the calculator. To do this, we add 2 more attributes to our calculator class. An accumulator variable, which is a double, and we will use it to store previous results. And a selected operation string, which will keep track of the last operation selected. The selected operation string is initialized with an empty string to represent an operation selected value. Now we can add the operations inside the action perform method, and let's start with the add button. If the source is the add button, there are 3 things that we want to do. First of all, we want to store the current value inside the text field in the accumulator. We are going to need it later when we are going to perform the operation. We store the plus sign in the selected operation attribute. This is to remember that the last operation selected is the plus operation. And we reset the value inside the text field to wait for the second number. The same logic can be applied to the other 3 basic operations, subtract, multiply and divide. You just need to select the right operation based on the button that has been pressed. Now, there are a few other buttons that we need to add. The first one is the negate value button. This button takes the value that is inside the text field and negates its value. To do that, we parse the value inside the text field to a double value by using the parseDouble method, and we negate it with a minus sign. After that, we just convert the new value to a string and assign the result to the main text field with the setText method. Another button that we need to implement is the clear button. This button just clears the current state of the calculator without the need to close the program. As for the others, we check if the source is the clear button, and if it is, we reset the current state by clearing the value inside the text field, setting the accumulator to 0, and clearing the currently selected operation. The last button that we need to implement is the equals button. As for the previous buttons, we check the source, retrieve the value currently inside the text field using the getText method, and convert it to a double using the parseDouble function. We then need to perform a different operation based on the one that has been selected. To do that, we use a switch case statement on the selected operation attribute, where each case is going to perform a different operation based on the value inside the selected operation variable. Now that we have the final result, we only need to reset the value inside the accumulator, reset the selected operation, and assign a newly calculated value to the text field. And that's it. We now have a working Java calculator and we can start the program to test it. This works as expected. We can add numbers, multiply them, and do basic operations. We can stop the project here, but there are a few issues that we have not considered. One problem is that we can add as many dots as we want. This is a problem because a number can only have one dot, and otherwise the number just doesn't make sense. Another issue is that if we click an operation immediately after launching the program, the calculator will try to parse an empty string as a double, which will throw an exception and cause the program to crash. There are also other problems, but these are the ones that we are going to fix now. For the first one, it's enough to ignore the input when a dot is already inside the text field. To do that, we add a condition to the if statement and check if the dot is already present by using the contains method. For the operations, we need to make a similar change. We only want to enter the if statement when there is something inside the text field. To check that, we use the equals method and we enter the if statement only when the value inside the text field is not equal to an empty string. The same applies to the negate button. We do not want to change the sign if the text field is empty. For the equals button, there are two things that we need to check. First of all, we need to ensure that an operation has been selected, otherwise we can just ignore the event. And we also need to check if there is something inside the text field, otherwise the parseDouble operation is going to throw the usual exception. And with that, the calculator is now finished. If you want, you can check the advanced version of the calculator on GitHub. It has a few more functionalities and you can try to implement them on your own. With that said, thank you for watching. If you made this far into the video, I hope this has been helpful to you. If you want, you can leave a like and subscribe. Again, thank you for watching and see you next time.